Welcome back. So today we're going to be talking about lesson 1.3, which is finding limits from a graph. All right. First of all, what is a one-sided limit? As you guys remember from the previous lesson, we talked about what value a certain function approaches as we're approaching a certain value of x. So as you guys remember, about whom we had him approaching, for instance, 2 from the left and from the right, and what y value he was approaching. That's from both sides. That's a two-sided limit. While a one-sided limit is what value the function approaches as it's approaching a certain value from the left or from the right, which we'll be seeing in this lesson. Okay, so first of all, a one-sided limit is the value a function approaches as you approach a given value from either the left or right side. Okay, how do I say, or how do I write that? What's the notation for saying that the limit is approaching a certain value from the left or from the right? Let's just write that down in our little box here. Let's call this our note box. So when we say limit as x approaches c minus the minus after the c, this basically means what value we're approaching from the left, what y value we're approaching as x is approaching c from the left. And limit as x is approaching c positive, that means what y value we're approaching as x approaches c from the right. That plus sign means from the right. Okay, so again, like we said, c minus means from the left, c plus means from the right. Let's see that with our example. The limit of f as x approaches 3 from the left side is -1. What does that mean? So again, let's have Barhum help us. Here x is 3. So as you guys can see, as Barhum is approaching 3 from the left, only from the left, okay? As he's approaching 3 from the left, what y value is he approaching? -1. So the limit as the function approaches 3 from the left. How do we write that? We said from the left means 3 and then we put a minus sign. There's a minus sign right there. For the function itself is -1. Okay, now let's have Barhum help us to see the limit of function f as x approaches 3 from the right side. So again, here's 3. Here's Barhum, and he's going to approach 3. As you can see, he's walking towards 3 from the right. As he's approaching 3 from the right, what y value is he approaching? 2. And what's the notation for that? How do we write that down? So again, here is 3 from the right. So we're going to put a plus sign. What y value did we get? 2. Okay, now, two sides are different. As you guys can see from the left, as we're approaching 3 from the left, we got -1. But as we're approaching 3 from the right, we got 2. So we're getting two different values. We're approaching two different values from the left and from the right. So therefore, the limit as x approaches 3, here I didn't say left or right, does not exist. The limit does not exist. Why does the limit not exist? Because we're approaching two separate values from the left and from the right. For the limit to exist, we should be approaching the same value. Okay, moving on. Let's see some examples on this. So here, we want to see the limit as x is approaching -2 minus. What does that minus mean? Exactly, from the left. So as you guys can see, here is -2. As I'm approaching -2 from the left, so here's Barhum, he's on our graph, he's helping us. He's approaching -2 from the left. What y value is he getting? 1. Now, we want to approach -2 plus, what does that mean? From the right. So basically, again, here's Barhum helping us. He's approaching -2 from the right. What y value is he getting? -2 as well. Okay, so as you guys can see, from the left, I got 1. From the right, I got -2. So therefore, the limit as x is approaching -2 does not exist. Again, why did we say that the limit doesn't exist? Because we're approaching a different value from the left and from the right. All right, let's move on. We want to find the limit as x is approaching 1. Here, as you guys can see, they didn't tell us that it's from the left or the right. So they have to approach the same value from the left and from the right. Let's see if that happens. Okay, so here's 1. As I'm approaching 1, here's Barhum, he's helping us. He's approaching 1 from the left and from the right. As you guys can see, as he's approaching 1 from the left and from the right, what y value is he approaching? Which is basically 1. What's the limit as x approaches 0? Again, here I didn't put left or right, so we have to approach the same value. So as you guys can see, as I'm approaching 0 from the left and from the right, what y value are we approaching? -2. Limit as x approaches 3 minus. That minus, like we said, means from the left. So here's 3. As I'm approaching 3 from the left, what y value am I approaching? 5. Okay, limit as x approaches -1. Let's see that. And as you guys can see, they didn't tell us from the left and from the right, so it has to be the same value. Okay, so as I'm approaching -1, so again, we can put Barhum here to help us out. He's approaching -1 from the left and from the right. What y value is he approaching? -3. Okay, f of 1. F of 1, again here, this is the instantaneous value of y when x is 1. So we look, x is 1 here. What's our y value when x is 1? Our y value is -2. Okay, I don't care about the limit. I don't care what value it's approaching. All I care about is that when x is 1, how much is y? -2. Same thing with f of -2. So f of -2, again, we're just going to be looking. Here is f of -2. We want the instantaneous value of y. So when x is -2, what's the value of y? 1. All right. Moving on. Sketching a graph. Sketching a graph is not going to be asked of you in the actual exam. This is just to help better help us understand limits and values. So I may draw a graph, your graph may be a bit different. They're not going to be exactly the same. So sketching a graph, you don't really have to worry about that much. It just helps you to visualize the graph itself. Okay, so sketch a graph of a function g that satisfies all of the following functions. Okay, let's take them one by one. So first of all, let's change up the color. All right, g of 3 is equal to -1. Let's put down these instantaneous values. So when x is 3, y is -1. So we have a point here. G of 3 is equal to -1. So we're done with that. Then they told us that the limit as x is approaching 3 is 4. What does that mean? That means as I'm approaching 3, from the left and the right, I should be getting 4. But I can't put a shaded point there because I know that as I'm approaching 3 from the left and from the right, I'm getting 4. But f of 3 itself is -1. You may draw it as, for instance, approaching 4 from the left from here or from there. There is no one specific way to draw it. That's why I told you your picture may be a bit different than mine. Okay, limit as x approaches -2 from the right is 1. So again, here x is -2. As I'm approaching -2 from the right, I should be approaching 1. So let's take this graph, for instance. As you guys can see, as I'm approaching -2 from the right, I'm getting a y value of 1. So we're done with that as well. G is increasing all from -2 to 3. So from -2 to 3, G should be increasing. So therefore, I will delete this because they told us that it's increasing. So this would be incorrect. Why? Because this is decreasing. So as you can see, from -2 to 3, our graph is increasing. So we're done with that as well. And we have the limit as x is approaching -2 from the left. So as I'm approaching -2 from the left, that limit should be greater than -2 from the right. So as we're approaching -2 from the right, we got 1. As we're approaching -2 from the left, we should be getting a different value or a greater value. So let's say it's 5. Again, this is just an assumption. You may draw it approaching, for instance, 4, 3, as long as it's bigger. So like we said, drawing graphs, there is no one specific way to draw it. You might get more than one. In the quiz that I have for you guys, there's more than one sketch and you can try them out. Okay, so I have a question for you guys. I want you to try it out. Good job. So I'll be seeing you with our next lesson, and that's the end of today's class.